Welcome to Tomorrow Unveiled. Look, if you thought humanity's push into the cosmos was, just a slow crawl, maybe think again this past week. It's been nothing short of extraordinary. Things are really accelerating our journey beyond Earth. So our mission today is to cut through all that noise, give you the essential insights from our dedicated research team, and really unpack what these rapid advancements truly mean for our future, obviously in orbit, but also right here on Earth. We're going to focus on the technological breakthroughs, which are pretty astonishing, the commercial expansion too, and the foundational infrastructure that's being built up there. We'll also touch on the inherent challenges, of course, and the fascinating geopolitical chessboard playing out above us. Yeah, it's a deep dive into how everything we're seeing beyond Earth is fundamentally reshaping our world. Okay, let's just jump right in then. Because the sheer pace, the number of launches, and this relentless drive for reusability in spaceflight right now, honestly, it's mind-boggling. I mean, the numbers our team compiled this week are just incredible.
They absolutely are. It really paints a clear picture. Unparalleled operational efficiency, really. For instance, the data shows SpaceX just hit this huge milestone, their 500th Falcon 9 launch.
500, wow.
Yeah, and what's maybe even more impressive and really highlights how routine reusability has become, Booster 1067. It just completed its 29th mission. Another successful landing.
29 flights.
Yeah.
I mean, that booster's almost got seniority.
Right. Think about that. Almost 30 flights for one booster. This isn't just a concept anymore. It's proven. It saves costs. It increases the launch cadence. It's reality.
29. Amazing. And talking about speed, our team also noted SpaceX launched 27 Starlink satellites just 13 hours after a previous launch from the same pad.
Exactly. That kind of turnaround. Unthinkable just a few years ago.
Yeah. But it's not just SpaceX pushing the envelope here, is it? What about Rocket Lab? They seem to be making some serious waves in the small sat sector.
Oh, definitely. Rocket Lab is setting new benchmarks for responsiveness. They clocked 4 Electron launches just in June. 4. Including their fastest ever turnaround, less than 48 hours between launches.
Less than 2 days.
Yeah. This demonstrates incredibly predictable and crucially responsive access for small satellites. Vital for a lot of customers. And looking ahead, they seem to be on schedule for the first launch of Neutron, their medium-lift rocket.
Ah, Neutron. That's the bigger one.
Right. Second half of 2025 is the target. And it's explicitly designed to compete directly with Falcon 9.
So they're going head-to-head, taking on the big players.
That's the plan. It tells you a lot about their ambitions.
What gives them that confidence, though? Competing with Falcon 9 is a tall order. And speaking of heavy lift, what's the latest from Blue Origin? Especially with New Glenn, we've heard about some challenges there.
Well, Rocket Lab's confidence comes from their track record with Electron, right? They've proven they can execute. And the Neutron design philosophy is all about rapid reusability and high cadence, much like Falcon 9. They learned the lessons. As for Blue Origin, yeah, New Glenn is aiming for its second flight by August 15th, the big objective this time. Successfully landing and recovering that massive first-stage booster.
Which they didn't manage on the first try.
Exactly. A step they missed on the first orbital attempt. But despite that, they're clearly committed. The research indicates plans to scale up manufacturing pretty significantly, aiming to produce 8 New Glenn second stages in 2025 alone.
8. Okay, so they're serious about getting into regular operations.
It certainly signals a move towards high-volume ops, yes. What's really striking about all these developments, when you step back, our team sees this clear dual-track development model emerging across the industry.
Dual-track? What do you mean?
Well, look at Rocket Lab, using profits from Electron, their smaller system, to fund the big Neutron project. Or Blue Origin, with new Shepard flights, helping to de-risk and fund the massive New Glenn development.
Ah, okay. Using the current earners to pay for the future giants.
Precisely. It's a much more, let's say, financially resilient way to tackle these incredibly high-risk long-term projects. It marks a departure from some historical development cycles, builds stability into a very capital-intensive industry.
So, pulling back even further, what does this all mean? Cheaper access, more frequent launches? It sounds like it's not just incremental improvement, it's fundamentally changing the whole space game, right?
Absolutely. Cheaper, more frequent, more diverse access to space. It reshapes everything.
Could it drive completely new kinds of businesses, things we haven't even thought of yet?
That's the exciting part. Lowering the barrier to entry always sparks innovation.
Okay, here's where it gets really interesting for me. Beyond just, getting stuff into orbit, what are we actually doing up there? What new capabilities came online this week? The advances in Earth observation and comms look transformative.
Indeed. Big news from Europe. The European Space Agency, ESA, successfully launched MTGS-1 and Sentinel-4 on July 1st. This new system offers something called hyperspectral sounding.
Hyperspectral sounding. Okay, break that down.
Think of it like taking a highly detailed 3D MRI of the atmosphere. It lets us see things like pollution plumes or storm precursors with just unprecedented clarity and speed.
So 3D views of the air itself.
Exactly. It monitors trace gases, pollutants like nitrogen dioxide, ozone, formaldehyde. It's absolutely game-changing data for forecasting severe weather and tracking air quality back here on Earth.
Wow. That's not just interesting science. That directly impacts safety and health, daily lives.
Precisely.
And sticking with communications, one of the most maybe surprising breakthroughs this week came out of China. Our team flagged that their scientists achieved 1 gigabit per second data transmission from a geostationary satellite using just a 2-watt laser.
That's right. 1 GBPs with a tiny amount of power.
That's potentially, what, 5 times faster than current Starlink? Is that right?
The report suggests potentially 5 times faster? Yes. It's a significant jump.
How big a deal is that for global communication? And could this really be a stepping stone to, say, 6G internet?
Oh, it's incredibly significant. Laser communication, or optical comms, has huge potential. This kind of speed and efficiency could dramatically improve global networks. Think remote areas, high bandwidth needs. It absolutely pushes the boundaries for space-based internet. And yes, it could indeed lay some foundational groundwork for future generations, like 6G. It's about getting past traditional radio frequency bottlenecks, moving massive data with less power.
Feels like science fiction becoming reality. Okay, and there's another emerging frontier, maybe a bit further out, quantum communication. Our research team noted an expanded partnership there between Singapore's Spectral and Thales Alenia Space.
That's right. They're aiming to jointly demonstrate satellite-to-Earth quantum key distribution, QKD.
QKD, and the significance is ultra-secure communication, like unbreakable.
That's the promise. It's a critical step toward a global, ultra-secure network. The physics of quantum mechanics itself provides the security. Trying to eavesdrop on the quantum keys fundamentally changes them.
So the act of spying trips the alarm.
Essentially, yes. It immediately alerts the sender and receiver. It's designed to be secure even against future quantum computers. A physically based solution.
That kind of security is going to be vital. And innovation isn't just about the data streams, it's the hardware too, right? We saw the U.S. Space Force awarding a $2 million contract to Atomic 6 for a foldable light-wing solar array. What's the big deal about a folding solar panel? Seems simple.
But this isn't just any solar panel. It's designed to be retractable and lightweight. It maximizes power generation when deployed, obviously. But crucially, it can retract to avoid debris collisions.
Oh, okay. Like pulling in your wings in a storm.
Exactly. In an increasingly congested orbit, that's a potential game changer for satellite longevity and safety. It points towards next-gen power systems more efficient, but also more resilient, addressing real operational challenges.
So we're optimizing how satellites work once they're up there. But what about the next logical step? Actually making things in space. It sounds like in-space manufacturing is really starting to take off, isn't it?
It absolutely is, and it's incredibly exciting. Multiple developments this week. For example, SpaceForge, that's a UK startup, launched their Forge Star 1 satellite. The goal, manufacturing advanced semiconductors in space, leveraging microgravity.
Using space conditions to make better chips.
Precisely. And maybe even more significant from a process standpoint, Varda Space just received an expanded Part 450 re-entry license from the FAA for their W-Series capsules.
Okay, Part 450 license. Sounds bureaucratic. Why is that a game changer?
Because historically, every space re-entry was treated almost like a unique one-off event. Very complex approvals. A Part 450 license signals that regulators are now viewing in-space manufacturing and, crucially, Earth return as a potentially routine, commercially licensable process.
So it standardizes the return trip, makes it repeatable.
Exactly. It opens the door for frequent space-to-Earth supply chains for these unique materials, turning experiments into a real business.
So we could soon be getting regular deliveries from space. Wild. And maybe even more relevant for future human missions. ESA, the European Space Agency, successfully conducted its first metal 3D printing aboard the ISS.
Yes, a major milestone, enabling crews to fabricate tools, components, spare parts right there on demand.
That's huge for long-duration flights, isn't it? Less reliance on Earth resupply.
Precisely. If a critical tool breaks, or a specific part is needed way out by Mars, you print it. Look, if we connect all these dots, the manufacturing, the return capability, the on-orbit printing, these aren't just theoretical advances, they're concrete steps. Steps towards a future where space isn't just for observation, but for active creation, for unique services, maybe even new forms of commerce originating from orbit.
It's shifting from space as a place we go to space as a place we do things.
It's a workshop.
Workshop.
Well put, exactly.
And it's not just about robots and satellites anymore, is it? Human ingenuity, human presence. That seems central to this expanding story, pushing boundaries. Commercial human spaceflight, in particular, seems to be really coming into its own.
Absolutely. AXIA Mission 4, which launched successfully to the ISS on June 25th, was a prime example. Our team noted this mission carried the first government-sponsored astronauts from India, Poland, and Hungary.
India, Poland, Hungary, on a commercial flight.
Yes, a significant new milestone in international commercial spaceflight cooperation. It shows the growing global interest and, frankly, accessibility.
That's fantastic. And our team highlighted a specific, really impactful experiment on board AX4, the Sweet Ride experiment, testing continuous glucose monitors, CGMs, and insulin stability in microgravity.
That's right.
What's the goal there? Beyond just space travel, I mean. Seems like a dual-use thing.
It absolutely is a crucial dual-use objective.
Yeah.
And it really exemplifies this new symbiotic business model for space. First, yes, it gathers data to potentially enable astronauts with diabetes to fly safely in the future.
Which opens up spaceflight to more people.
Exactly, expanding the pool. But second, and maybe more importantly for us down here, it's validating robust medical monitoring technologies that could be adapted for remote or harsh environments on Earth.
Like disaster zones or really rural areas.
Precisely, where medical access is limited. So space acts as this unique R&D lab to solve high-value terrestrial problems, which in turn expands the customer base for commercial spaceflight. It's a win-win.
Bringing tangible benefits back home, that's a powerful example. Space R&D for Earth problems. And beyond the ISS, we're also seeing suborbital space tourism maturing, right?
Yes, very much so. Blue Origin just had its 13th crewed New Shepard flight. NS-33 carried 6 private astronauts. Our team mentioned this brings the total number of people who've been to space, depending on how you define it, to 750.
750 people, that number's climbing fast.
It is. And the reliable recovery of both the booster and the crew capsule, flight after flight, it demonstrates really mature suborbital transport tech. Good for tourism, sure, but also for quick microgravity experiments. Up and down.
Okay, looking further ahead now, the future of orbital habitats. That's a hot topic, especially with that confirmed 2030 deorbit date for the International Space Station. Our research team notes funding is allocated for its safe deorbit. There's even a contract for a U.S. deorbit vehicle to guide it down.
Yes, the plan is firming up.
So what's the strategy? How do we maintain a human presence in low Earth orbit after the ISS is gone?
Well, that firm timeline really forces the issue, doesn't it?
Sure.
It creates a critical transition period. NASA is relying heavily, explicitly, on the private sector to bring the next generation of orbital habitats online.
Commercial space stations.
Exactly. Companies like Blue Origin developing Orbital Reef, AXIA building its station modules, and there's strong international interest too. ESA, the European Space Agency, signed an MOU with Blue Origin.
To use Orbital Reef.
To explore opportunity for using it, yes. So this period, the next, say, 5 or 6 years, it's crucial. The commercial space industry really has to deliver on the promise of these next-gen orbital platforms. That's the plan to ensure a continuous human presence in LEO through commercial endeavors. You know, this raises a really important question, though. As we shift from this largely government-funded ISS era to commercially operated platforms, how does that change things? Not just who gets to go, but the types of research, the manufacturing, maybe even tourism that become routine.
It's a fundamental shift in the economics, the purpose.
Yeah.
Everything.
It really is. A whole new chapter for humans in orbit.
Okay, before we delve into some of the inherent challenges and the complexities of this expanding frontier, just a quick word for you, our listeners, who make Tomorrow Unveiled possible. If you're finding this insightful, maybe you're watching on YouTube, please take a moment to like this video, subscribe to Tomorrow Unveiled, of course, and be sure to turn on notifications so you never miss an update on the future. And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps us reach new listeners, and we really do love hearing your thoughts. So whether you're on YouTube or your favorite podcast app, leave a comment. Let us know what you think about this week's breakthroughs and challenges beyond Earth. All right, so pushing boundaries always comes with hurdles, right? let's talk about the bumps in the road. Because understanding them is crucial for getting a realistic picture of the future. Our team flagged some significant technical setbacks and, well, execution risks just recently.
Absolutely. Space is hard, as they say. The SpaceX Starship program, for example, hugely ambitious, but it continues to face challenges. There was a recent explosion during ground testing. Previous test flights haven't all been successful. It just really underscores the immense difficulty in mastering propulsive landing and full reusability for these super heavy lift systems.
It's a tough engineering
A
problem.
massive one. It's a painstaking, iterative process, learning from each attempt. Similarly, Blue Origin's New Glenn, as we mentioned, had that booster recovery failure on its first orbital attempt, again highlighting the inherent challenges of bringing entirely new heavy lift systems online.
And it's not just the newer players, is it? Established agencies face setbacks too.
Indeed, very true. Remember JAXA, the Japanese space agency? Their H-3 rocket debut failure back in 2023 was a significant blow, resulted in the loss of a multi-billion-yen satellite. Yeah. These incidents are just stark reminders of the inherent risks. It's complex technology. And even after a successful launch, the challenges aren't over. Our team pointed out the $88 million Methanosat climate monitoring satellite. It failed after just 1 year in orbit.
Only a year after all that investment.
Yes, a significant loss of investment and scientific potential. It's a reminder the space environment itself is harsh. It can lead to premature mission ends.
These failures, while obviously not good, they do provide crucial lessons, I suppose, learning opportunities for the whole industry. But alongside these technical risks, there's this growing concern about space debris and the environmental impacts from all this increased activity. I saw reports flagged by our team about a new kind of pollution from re-entering satellites. What's that about?
It's a very real concern, and it's getting more attention. As more satellites, especially from these mega constellations, burn up on re-entry, they're depositing large amounts of aluminum, other metals, into the upper atmosphere.
Okay, stuff that wasn't there before in those quantities.
Exactly, creating this new kind of pollution. The long-term effects on atmospheric chemistry, still being studied, frankly. But regulators are taking note. The proposed EU Space Act, dated June 25, 2025, our researchers see that as a direct policy response.
We would propose.
Mandates for better debris tracking, stronger cybersecurity for satellites, and it encourages satellite servicing, repairing, or refueling satellites in orbit to boost sustainability.
Trying to clean up our act in orbit.
Essentially, yes,
Yeah.
it highlights the urgent need for robust regulation for long-term space safety and environmental protection.
Okay, beyond the technical and environmental, there's this fascinating geopolitical chessboard at play. Our team noted a pretty significant incident recently. Mexico threatening legal action against SpaceX after that June 18th Starship test stand explosion, alleging contamination of Mexican territory.
Yes, that situation is ongoing.
This isn't just a technical issue, is it? It's a complex international law challenge.
It absolutely is. This incident raises really significant questions under international law. Things like transboundary environmental impacts from space activities. Who's liable? What are the standards for contamination?
Questions we don't really have clear answers to yet.
Not globally agreed answers, no.
Yeah.
The world is only just starting to grapple with these issues as space activity scales up so dramatically. And if we look at, say, the U.S. military space strategy, our team's research illustrates this sophisticated, dual-pronged approach reflected in recent contracts. On one hand, Boeing got that huge $2.8 billion contract for the Evolved Strategic Satellite Communication System, ESS.
ESS, okay.
Designed as a fortress in the sky, basically, for critical nuclear command and control, operating from high geostationary orbit, very hardened.
Right, a super secure, high-value asset, like the crown jewels. But at the same time, we're seeing Rocket Lab passing a critical design review for the Space Development Agency's Tranche 2 Transport Layer Beta program, T2TL Beta.
You're right.
That involves building a proliferated network. Lots of smaller, more affordable satellites in low Earth orbit for tactical comms.
Exactly.
So what's the strategy there? Having both the fortress and the distributed network, why not just one?
Well, it's not just two different systems. It's seen as a smart, resilient, dual approach. ESS provides that super hardened, high-value capability, essential for top-tier national security comms. While the SDA's T2TL Beta constellation, with its many smaller, cheaper satellites, offers resilience through numbers, redundancy.
Ah, so if one or two get taken out, the network still works.
Precisely. If one or even several are targeted or fail, The whole network isn't compromised. It makes it much harder for an adversary to disrupt critical communications. It shows a sophisticated response to modern threats, pursuing both exquisite, highly capable assets and resilient, mass-produced networks.
A strategic balance, then. Makes sense.
No,
And other nations are clearly focusing on self-reliance in space, too. India, for example, making big moves.
absolutely. India's Strategic Technology Transfer Initiative is a prime example of this global trend. ISRO, the Indian Space Research Organization, facilitated the transfer of 10 state-of-the-art space technologies to 6 private Indian companies.
Giving their private sector a boost with government tech.
Exactly. The purpose is clearly stated. Build sovereign capability. Achieve Atmanirbhar Bharat, which means self-reliant India, in this critical sector. Reduces reliance on foreign imports, fosters a vibrant domestic space ecosystem. It's a pattern we're seeing globally. It was really fascinating here, tying it all together. Despite the incredible growth of the commercial space sector, the primary force still shaping the industry, it remains sovereign national interest, geopolitical competition.
National goals still trump purely commercial ones.
Often, yes, or at least heavily influence them, which means regulatory frameworks. They become an increasingly critical and often, frankly, slow-moving factor for any space venture, influencing everything from launch licensing to orbital operations to data sharing.
Okay, so as we bring this deep dive to a close, what does all of this mean? All this incredible, challenging, hopeful news for our future, for humanity's journey beyond Earth.
Well, the key takeaways from the information our team gathered seem pretty clear. First, we are undeniably in an era of unprecedented technological acceleration in space, driven largely by this relentless pursuit of reusability and efficiency is changing everything. Second, space is rapidly becoming this multifaceted platform. It's for advanced Earth observation, yes, but also quantum secure comms, in-space manufacturing, even critical medical R&D. Third, human presence in orbit is evolving. There's a clear, if challenging, transition towards a commercially operated future in low Earth orbit.
Right. But as we've discussed, this expansion comes with those inherent technical risks, growing concerns about space debris, environmental impacts, and navigating that really complex geopolitical and regulatory landscape. And importantly, as you said, national interests are increasingly tangled up with commercial space, shaping defense strategies, economic self-reliance.
Absolutely. Looking ahead, what can we anticipate based on these trends? Our team expects increased market volatility, probably aggressive pricing pressure in launch services as these new heavy-lift vehicles finally come online and compete. Expect a wave of innovation in downstream data analytics. All this new high-res Earth observation data has to be processed and turned into insights.
Making sense of the flood of data.
Exactly. And the next 3 to 5 years, they'll be absolutely crucial for the commercial space station providers. They need to deliver on their promise of next-gen orbital platforms. That will really determine the future of human presence in LEO post-ISS.
And on maybe a grander strategic scale.
We'll likely see the real ignition of a long-term strategic competition among major global powers to develop and control these quantum-secure communication networks we talked about. Security is paramount, and the model of national space development itself will continue to evolve. More nations fostering these self-reliant, vertically integrated domestic space industries, like India is doing. This raises a final important question, maybe something for you to ponder. As humanity ventures further beyond Earth, will this immense drive for national advantage, for commercial profit, will it ultimately converge with a collective need for sustainable, collaborative exploration? Or will it lead to new divides, new challenges, things we'll have to consciously work to address? It's an open question.
That's a powerful thought to end on. Collaboration versus competition in this final frontier. And for you listening, maybe consider how these accelerating developments in space, often happening way out of sight, how they're quietly reshaping everything from global security and climate resilience to how you might receive healthcare in the future or even the materials and products you use right here on Earth. The future is truly being built, not just down here in our cities, but potentially light years away. Thank you for joining us on Tomorrow Unveiled. We really encourage you to share this deep dive with others who are curious about what lies beyond Earth.